Hello, and welcome to the ADIAT version 2.1 launch spotlight. I'm very excited to be here to share some of the new features and capabilities today. We're going to spend most of our time in the tool itself, but before we get started, I want to take a moment to say thank you, as always, to the ADIAT community. Thank you to the users who choose to use ADIAT for image analysis in search and rescue, and especially thank you to those who contribute both directly and indirectly to the project. As you're probably aware, ADIAT is an open source software project. That means the code base is freely available online. And we do that so that people within the search and rescue community and elsewhere in the software development community can directly contribute to it. They can build additional features and capabilities or enhancements, and that code becomes part of the ADIAT code base and part of the tool that we are able to make freely available to search and rescue teams. So, again, thank you so much to everyone who directly and indirectly contributes to ADIAT. Now, as far as what we're going to be taking a look at today, we have a brand new thermal algorithm. It's called the Temperature Residual Anomaly Detector. We'll take a look at that. We have added our existing AI Person Detector that you've seen on the image analysis side to the real-time streaming side. So if you have video coming in from the drone real time or you're analyzing video, we can use that detector now and it will identify people in that streaming video. We've made some huge improvements again to the image analysis viewer experience. We'll take a look at each of those. And we've also made some updates to the overall platform. The first being that it will now include an auto update capability. So you may notice in the future, when you go into ADIAT, there'll be a little dialog that pops up saying, hey, there's a new version of ADIAT. Do you want to go ahead and update? And that makes it so that you don't have to keep going back to the ADIAT website and being aware that we've made updates. It will tell you directly in the app. So hopefully this is the last version of ADIAT that you will have to go to the website and directly download. The other big update on the platform side is multi-language support. So historically, ADIAT has, of course, been available in English, but that limits the potential user base. Thanks again to the contributions from the ADIAT community, we are now able to offer multi-language support. So beyond English, we have Italian, Spanish, and Dutch available. Thank you so much to Alicio, Sandro, and Ron for making those translations available. If you feel comfortable and would like to provide translations into another language, please feel free to reach out. We would always, of course, love to make the tool available to a larger community, and especially now in locations where people may not be as comfortable working in English. So again, feel free to reach out to adiat@texar.org, and we can help get you set up if you're interested in doing translations into an additional language. Before we jump over to ADIAT itself, there is one concept I wanted to talk about, and this is a capability that has been introduced in version 2.1. It's not always going to be the most readily apparent in the application itself, other than it's going to drastically improve the accuracy of our ability to locate areas of interest within an image. As you might remember, in version 2.0, we introduced the ability to locate not only the drone, of course, but also areas of interest within an image. But it was with the caveat that it was assuming the area represented in the image was flat, because that was the only way we could do the math. With version 2.1, we've moved beyond that thanks to a concept called digital elevation models, or DEMs. So if you're not familiar, a DEM is basically a representation of the bare ground topography. So it is just the earth itself. Take out the trees, take out the vegetation, take out buildings, any other surface objects, and just tell me what the elevation of the actual ground is. And we can download DEMs for specific areas. As you might imagine, if you try to download a digital elevation model for the entire earth, it would be gigantic files. So we have the ability through some services to download elevation models for the specific areas that are represented in your mission area and use that to more accurately get a more accurate representation of what the ground elevation changes are. Now, why is this important to us? As I said, in version 2.0, when we were trying to locate AOIs, we had to do it with the assumption that everything in the image was at the same elevation, and it was all the same elevation relative to the elevation or altitude of the drone when the image was taken. So in this representation here that we see, we have our image. We're going to say, for the sake of simplicity, that we're pointing north. This orange box represents our drone. We've got completely flat ground. So when we introduce our AOIs, let's say we have these three here, it's pretty simple to calculate their relative distance from the drone. And from that, as you can imagine, we can fairly simply go ahead and determine their actual location. Again, everything is simple when the area in the image field of view is flat. When we move to a scenario where we're not talking about flat ground, that gets a lot more complicated. If we applied the same math to this, where we're looking at the face of a cliff, it would say this first one is 20 meters away, the second one is 30 meters away, the other one is 40 meters away, which we know isn't accurate. If we were actually going to look at this from the top down, all three of those dots would probably have pretty much the exact same latitude and longitude. They just happen to all be along a vertical line of a cliff face. So by leveraging the digital elevation model, we're able to more accurately say, hey, this AOI is 20 meters away, so we can calculate its coordinates. And by the way, because we know the elevation is pretty much straight up from there, these other two are going to have pretty much the exact same coordinates as well. So that concept carries through to all of our maps, all of our AOI locations, all of our reports, and more accurately allows us to provide the information to you so you can provide it to your search managers and ground teams to say where an area of interest actually is. Again, as always, a huge thank you to the ADIAT community for making this possible. Alicio with the Italian National Alpine and Cave Rescue Organization, as well as always, John O'Keefe with Eldorado SAR worked on this, various portions of this to make this available in ADIAT. So thank you. It goes a long way to allowing us to provide more accurate location information and getting teams in the right place. With that, let's go ahead and jump over to ADIAT and start looking at some of the other new features. All right, we are over in ADIAT now. If you've been using version 2.0 of ADIAT, this screen probably looks familiar to you. This is the newer landing page where we make our first decision. Are we going to be doing image analysis, so post-flight image processing, or are we going to be doing stream analysis, either of a live feed coming in from a drone or analysis of a video file? We're going to spend most of our time in the rest of this session over on the image analysis side, but let's start with streaming. And specifically, we're going to look at that AI Person Detector algorithm. So I'm going to click on Stream Analysis, and that's going to take us into our streaming setup guide. So again, if you didn't get a chance to watch the 2.0 videos, or maybe you're not familiar with earlier versions of ADIAT, one of the things that we added in 2.0 is this setup guide, kind of guided path experience for getting going in ADIAT. What we were realizing was we were adding a lot of great features and capabilities to ADIAT, but that was making it a little more intimidating, especially for new users, and created a really steep learning curve. So what we introduced in 2.0 is this setup guide process where instead of just throwing a wall of settings at the user their first time coming in, they can go through this wizard approach instead, and we'll walk you through it step by step, question by question in plain English, and get you to the same result. We'll just kind of set the settings for you behind the scenes. So with that, we're going to start our stream setup. We're going to do a file for the purposes of our demonstration. So I'll go ahead and click continue, and then we'll go ahead and grab the file that we're going to use. We can go ahead and leave our processing resolution at 1080p. Technically, we could go a little higher if we wanted to, all the way up to 4K, but for now, let's leave it at 1080p. I'll go ahead and click continue, and that'll take us to our video capture information step. So this is where we select the drone that was being used, as well as how high above the ground it was flying. Now, if you've seen the image analysis side in that setup guide, we're able to set both of these for you. It's available in the meta information for the image. Unfortunately, that's not the case in the video, especially the AGL altitude, because of course the drone can change altitudes throughout the video. So we're going to go ahead and set it based on a best guess of where we were, kind of an average throughout the video, as well as set the drone that was being used. Once we have those two values, we can see the ground sampling distance calculations down here. And really what this feeds into is, in combination with this, our next step, what size of area of interest are we looking for? So first we set the drone parameters. Now we set, hey, here's what I'm actually looking for. Now we're going to be testing the AI Person Detector. So I'm going to go ahead and set this all the way up to anything from a small article to a person recumbent, so a person lying down. It'll only look for areas of interest that are in that size window for us. Continuing on, we get to our algorithm selection decision process. So this is basically a decision tree, and we're just going to be asking questions to determine what the best algorithm is for a particular scenario. Now, if I go ahead and say in this first question, are you primarily looking for a person? And we say yes, well, that's the end of the process. So not that interesting to demo. But if we go back and we say, hey, no, we're not looking for a person. Are we looking for a specific color? Yes. Then we'll say, okay, use the color detector, etc., and so forth. So, but for our purposes, we actually are looking for a person. So I'm going to go back and say yes on that. And I'm going to go ahead and click continue. And that takes us to our one question for setting up the actual AI person detector. And that is, how confident should ADIAT be before marking something as a person? And this is really our risk tolerance or false positive tolerance, false negative tolerance. I tend to leave it on the balance to permissive side, which will include more false positives. I imagine most people in search and rescue are in a similar boat. We're much more okay with having false positives than having a false negative in missing the person. So I'm going to go ahead and leave it balanced here and click on Open Stream Viewer. And that takes us into the main real-time stream viewer experience. Now, if you haven't watched that video from ADIAT 2.0, I highly recommend doing so. We're not going to walk through everything that's on the screen here. We're just going to focus on the pieces specific to the AI Person Detector. First one being the actual algorithm selection. You see we have our three options here: anomaly detection, color detection, or AI person detection. We have down here our actual person detector settings, so we can force the model to use the CPU. Getting in the technical weeds here, again, for the vast majority of people, there's no reason to ever check that box unless you're really struggling for some reason, or the system's really struggling trying to use the video card for analysis. And the next one, there's a couple of variants of the model. Again, pretty far in the technical weeds. There's one model that's the 1024 model, which uses slightly larger tiles. There's the other, which is the 640 model, which is a little more performant, with some drawbacks as far as basically you're downscaling the image. So it is in some cases more likely to miss something. So I'm going to leave those as is, just as exactly as it came in from the setup guide. And I'm going to go ahead and click connect, and it will start doing that analysis for us. You see it's going along here, and then it says it finds a person there. Now that might be confusing at first, but if we look down here or we look at the gallery, yes, there is certainly the truck there. But at the very front of the grill, or I guess that's the SUV next to the truck, there is actually a person standing there, and that is what it is picking up. So doing exactly what we hope it would do. It found a person even in a confusing environment like this next to another unexpected feature, especially in a wilderness search and rescue scenario, standing at the very front of a vehicle. It was still able to pick out the person. That's really what I wanted to cover on the stream analysis side. We're going to go ahead and get back to the landing page and go down the image analysis path. All right, we're back to where we started with our image analysis and stream analysis selection dialog. And this time we're going to go down the image analysis path. So I'm going to click on that. And I'm not actually going to look at this in the setup guide or setup wizard. I'm just going to go to the main viewer. Really, the only change we have in version 2.1 that impacted the setup guide is the addition of the new thermal algorithm, but we can look at that in the main window. If you ever want to exit out of the guided path, you can click close down here, or if you want to always skip it, you can check that box first and then hit close, and that will take you over to the main image analysis setup window. From here, we traditionally jump into setting up our analysis process and running it. But before we do that, I want to take a look at some changes to the preferences. So if we go up here to menu and go down to preferences, that'll load the preferences dialog and a couple of new things you'll see here. The first is our language selector. So by default, when ADIAT installs, we're going to try to match your operating system language. If we can't do that, we'll just go ahead and default to English for now, but you can always come into preferences and change it to whatever other language we support that you prefer. Next is the terrain section, and this is where we get into that digital elevation model we talked about. So this is basically saying, hey, I want to go ahead and use that feature. If we have this disabled, we fall back to basically the version 2.0 ADIAT model, where we're just going to assume the elevation is flat throughout the field of view of the image, which will potentially cause slight variances between the AOI location and the ground truth location. So if we leave that enabled, and we have an elevation source selected, we'll be able to use that digital elevation model for more precise location of areas of interest. One thing to note here, if we do have offline only mode turned on, we will honor that for terrain elevation as well. We're not going to be downloading terrain tiles if you've already said, hey, I don't want you to download anything. So just know that if the offline only mode has been ticked, then regardless of the terrain settings here, we're not going to be downloading anything behind the scenes. Now, as far as our elevation sources go, there's a couple available. The first is the AWS Terrain Tiles system, which is a publicly available free system managed by MapZen. And this has, at worst, 30-meter resolution. So a 30 meter by 30 meter square on the ground would have essentially the same elevation profile. In many regions, it is has much higher fidelity than that. So it's not going to be a 30 meter by 30 meter square, all saying it's the same elevation. It's going to be much smaller than that and much more accurate than that. Now, the other option we have is to use the USGS 3.1 meter source. So this one, as you might imagine, has a much higher level of fidelity. It's down to 1 meter, but there's a couple of caveats here. One, since it's USGS, it is US only. And two, you have to manually download the tiles yourself, either before or after you capture the area. Whereas with AWS terrain tiles, we'll automatically download them in the background based on the area that is flown. We'll basically geofence it and say, hey, we need the tiles for this area. We need the elevation data for this area. Unfortunately, we can't automate that process with the USGS data. You have to go ahead and provide the manifest of tiles and go ahead and download the tiles directly. The last section that has been added down here is canopy data source. Now, without context, this one's going to be a little confusing, but just now we'll see it in the image results viewer here in a few minutes. But the setup process looks very similar to something like the USGS elevation source information up here. But what we're capturing here, what we're downloading here is canopy height information. So we get an understanding of how high the vegetation is in an area to help start to calculate things like probability of detection. So just know that is in here as well. There's a few canopy sources here for you to choose from. And likewise, if offline only mode has been selected, we will not download canopy data either. So I'm going to go ahead and set this back to my defaults. Click closed and come back to the main viewer. Now, one more thing up here in the menus, we talked about auto updates. It will trigger automatically when ADIAT loads, but you can also come up here to the help menu and click check for updates. And that will run a quick online check to see if there are any newer versions of ADIAT available. If not, it'll tell you that. You can go ahead and click OK and move on. Again, the automated check won't happen if you are in offline only mode. So one more thing to just make sure you're aware. Now that we're back in the main analysis interface, I'm going to go ahead and set up an analysis run just so we can see some of the new features in the results viewer. You will notice there's another new option here. We'll take a look at that at the end. But for now, let's go ahead and set up our demo. Let's go ahead and say we're going to do a color match. Again, I highly recommend, if you haven't done it, look at some of the earlier videos. We'll go into this process in much more detail. Right now, I'm just going through it quickly just to get to the results. So we have our setup ready to go. We go ahead and click start. You will notice down here at the end, we'll give you a little bit more information than we previously have of where we are in the analysis process. So just another new status bar down here, especially for some of those longer runs, gives you a much better idea of how close you are to completing the run. But we've gone ahead and completed this. We did our 158 images in about 6.5 seconds. We had 45 images with 65 areas of interest in them. And now I'm going to go into the results viewer so we can look at some of the new features there. All right. A couple of things off the bat. As soon as we open this, you'll notice that every AOI has been assigned a number now. And now instead of just being able to jump to a specific image, we can go to a specific AOI. So in this case, we have AOI number 1. If we switch over to gallery mode, we can see all of our AOIs across all of the images. So again, just easier if we want to navigate to a specific AOI instead of trying to navigate to a specific image, we can do that directly in the interface. Go ahead and toggle off gallery mode for now. Now, another new feature you'll notice, if we click on an area of interest here, we jump to it, but we also provide a relative size scale here, just trying to provide context of how large these things are compared to the surroundings. It can be tough, especially at higher ground sampling distances, to really get a sense of how big something is. Is it the size of a backpack? Is it the size of a sleeping bag? Those sorts of things can be hard to discern without some sort of measurement close to the AOI itself. So that has been added. If you don't want that to be shown, we can come up here to our setup bar and go ahead and turn off the AOI ruler. And then we get back to basically where we were in version 2.0, with the exception of we do have the AOI number here as well. That's helpful, especially in images where we have multiple AOIs in the same image, so that we can keep track of which one we are looking at any given time. The next new feature I want to take a look at is our histogram tool. Now, this is a very different experience if you're looking at a color image versus a thermal image. So right now we'll focus on the color image experience. They're both launched from the same place up here in the toolbar, little line chart. If you click on that, in this case, as with a color image, we'll open our hue-based histogram view. Now, if you're familiar with the HSV color space or not familiar with the HSV color space, hue, which is what we typically think of as color, is represented as a 360-degree wheel here. And what we've done up here is basically flatten that and bucketize each of the pixels in the image into its hue section. And as you see, as we mouse over one of them, we'll highlight the pixels in the image behind that are in that hue space. Now, as we zoom in with our mouse wheel, you'll see we get higher and higher level granularity, so we can come even closer to isolating very specific hues if we want to. Down here, we can isolate specific hues in the image itself. So let's say we're looking for blue, as is the case here. We can go ahead and adjust the hue range and say, hey, only show me the pixels that are in this part of the hue circle. And as we move this out of the way, we can see that it really focuses on that AOI that we've already identified. So again, just another tool to allow us to isolate specific portions of the image based on color. Likewise, let me go ahead and reset the range here. The other option we have is to focus the histogram itself only on the areas of interest. And not surprisingly, in this image, if we go ahead and say AOIs only, it isolates, and the only area or the only section of the histogram that has any values is that blue shirt that we were looking for to begin with. Closing out of that, let's go ahead and look at our next feature, which is going to be our person size reference tool. So if we come up here to our toolbar and click on the person icon, and I'll go ahead and show a person lying down for now, we'll see we add an overlay of a silhouette of a person. And again, this is just to provide a size reference. So if we can drag this up towards where our area of interest is up here in the corner, what this does is it allows us to get a sense of, hey, is this object we found, this area of interest, the correct size and relative shape to be a person in one position or another, and of a certain size or another. And very quickly from this, we can discern, no, this object is way too small to be a person lying down. Even if we go ahead and rotate that shape, obviously in no position is it going to be the right size for a person in a lying down position. But we can also change it. So instead of showing a person lying down, let's go ahead and show the silhouette of a person standing up. Now here it's interesting because that could definitely be the right size for a person standing up. But we also have the ability to show shadows based on the actual sun position or estimated sun position when an image was captured. So if we go ahead and turn that on, we can see a person standing up that's 5'7" would very much cast a shadow that is significantly larger than anything we're seeing in the shadows from this shirt here on the ground. So again, we can use that information to rule out that this area of interest is a person. Obviously, we could do that looking at it, but again, in other scenarios, it may not be that obvious. So another tool, another overlay to try to provide some context about what the relative size of a subject would be if they were visible in an image. Next, we're going to look at some updates to the GPS map view and specifically the integration of the canopy information and a beta version of a probability of detection overlay. So this is going to leverage a few different components, one of those being the actual canopy information. So when we open our GPS map view, if we don't get a dialog asking us to do so, we can come down here and click on download canopy tiles, and that'll bring up this dialog. And basically, again, this goes back to some of those preferences we talked about earlier, but it's pulling in the information we need to generate the canopy, a realistic view of the canopy of the area that we have flown. So I'm going to go ahead and turn off the USGS one because we do have AWS information already available, but I am going to tell it, hey, go ahead and download the canopy height information. And up here, you see there's a couple of options. We can either download for a specific subsection or the entire mission extent. This is a fairly small mission, so we'll go ahead and download for all that. Click on download. You'll see it'll start downloading that information very quickly in this case. Have that available, and then we click OK, and then it's going to ask, hey, we have the coverage data available now. Do you want us to go ahead and start calculating probability of detection heat maps for this mission? We'll go ahead and say yes. Again, fairly small area, so it is able to do those pretty quick. Now, this is very much in beta at this point, but what you'll see here is we have the opportunity to do some probability of detection overlays. I'll go ahead and turn that on. And then we see we have the option to just show our canopy height information, look count, or the actual POD. And what that's doing is saying, hey, based on the canopy density, based on the canopy height, based on how many times an area or a particular spot was captured in images, what is a beginning of a estimation for probability detection? And I know I'm hedging a lot of bets here, but again, very early on, we just wanted to include this in here so people will start to see it. As you see, if we're in this view and we right click with a mouse, it'll go ahead and provide a POD value, but more than anything, what's valuable at this point is looking at it at the macro level and saying, okay, yellow means we had pretty good coverage throughout this entire area. There weren't a whole lot of blind spots to this particular section that we were mapping. Likewise, once we click on this, you can see there's some additional goodness here that we can see individual images that captured that particular point. So again, all things that have been added in the latest version of ADIAT. The next tool we're going to look at is also a good reminder that not every tool available in the image viewer is available in the toolbar. At some point, there would just be way too many icons up here, so some are only available through keyboard shortcuts. If you come up here and click on the help icon, you'll see the full list of keyboard shortcuts, including how we access the next tool we're going to talk about, which is the align image dialog. And if we close out of this and go ahead and hit A on the keyboard, it'll bring up that dialog. And what this is for is scenarios where that GPS value provided by the drone isn't exactly on with the satellite imagery. And we need to do a tiny bit of manual manipulation to make sure everything is correctly positioned so that when we're putting locations on AOIs, they are dead on accurate. You'll see as we pull these around, there's the difference in the overlay of the image versus the satellite image underneath. And really, what we're trying to do is do whatever manual alignment is required there. Again, only required, hopefully not very often, but if for some reason your GPS readings aren't very accurate, you may need to come in here and manually make some adjustments so that all of your location information does align correctly. The next tool we'll be looking at is Grid Review System. If we come up to the toolbar, you'll see this 4 square icon. Clicking on that will superimpose a grid on one of the 4 quadrants of the image. So our goal in ADIAT is to, wherever possible, do programmatic image analysis using our algorithms. But we do understand that there's always going to be scenarios where you're going to have to do manual analysis of images. And this grid review system is to help facilitate that process by providing a systematic approach to doing that analysis, providing grids and subgrids within those grids so that you can focus on one specific area at a time doing your analysis before moving on to the next one. So we can go through that manual analysis looking at the 9 grid section here. And then using our keyboard shortcuts, we can move it over to the next large quadrant and then continue that process with the final 2 quadrants. Again, tools we've shown before in previous walkthroughs, there's the ability to manually annotate images and add areas of interest in ADIAT. So as you're going through this manual analysis process, we can still leverage some of the tools within ADIAT to create reports, to create map, to do all those things, even if we're not getting the most out of the programmatic aspects of the image analysis. Next, we're going to look at a new feature that is part of our AOI filtering system. So if we come up here, click on our funnel icon, that'll launch the Filter AOIs dialog. And we have a lot of filters available here. If we scroll down, we will see a new one that is detection density heat map based filtering. And really, what we're trying to do here is filter out any detections that are really lens defects, camera defects, anything like that, not true areas of interest. And those are often going to show up in the same place in the image every time. Because, for example, if it's a lens scratch or it's chromatic aberration or something like that, it's going to be showing up consistently in the same places from one image to the next. So this system allows us to identify where those hot zones are, where we keep seeing detections over and over, and go ahead and filter those out. And there's a couple of neat things in here. We can view the heat map, and that'll show us where all the detections are. So you see in this set, for the most part, it's pretty well distributed, but there are a couple of high zones here where we see more detections than we do everywhere else in the images. If we want to, again, we can take that and say, hey, filter out the hot zones. So take away any AOIs that were in those hot zones. Or if we want to see kind of what those defects are and confirm that those are indeed something we want to filter out, we can show only hot zones first. and see what those detections are, what those abnormalities are, and confirm that they are, in fact, lens defects or camera issues or chromatic aberration or what have you that we do, in fact, want to ignore. Exiting out of that, we do want to look at one more feature we have here in the new image viewer experience, and that is the ability to group like AOIs. So I'm going to switch over to gallery mode really quick. And as you've seen in the GPS map and other views, this is a fairly small search area with a lot of overlap. So we see the same result over and over and over. And oftentimes we're going to want to group those together. So what we can do is we can click on one of our AOIs and click this Find Similar AOIs button. And what that will do is do a little search in the background, and it's going to come back and say, hey, here's the one that we selected as the reference. Here's how close all these other ones are to it. And that just gives you a sense of, hey, are we looking at the same thing over and over again? And we can go ahead and select all of those and flag them all together, or add the same comment to them, or unflag them. Again, instead of having to go one by one through all of these AOIs that are showing us the same thing, we can flag them all at the same time or do stuff in bulk. So just a time saving tip and a new feature that was added. With that, I'm going to close out of the image viewer. So we're back here on our main image analysis setup page, and we're going to be taking a look at our new temperature residual anomaly detector. But first, I want to talk a little bit about the original temperature anomaly detector so we can talk about kind of the comparison of the two. The original detector, we set our anomaly types that we're looking for. Are we looking for things above or below the mean temperature in the search area? We set our threshold, which was the number of standard deviations above or below the mean that we were looking for. And then we set our image segments, which is where we divide the image basically into a grid. And each one of those segments became its own search area for the anomaly detector. The residual anomaly detector is somewhat similar in concept, but much more dynamic and fluid in how it defines the search area. So rather than the hard and fast grid of the image segmentation, it's just going to look at neighboring pixels, and it's going to be kind of like a sliding window going up and down and across the entire image. So rather than a very static segmentation, it's much more dynamic in nature, and honestly probably does a much better job of detecting residual anomalies in localized areas. The variables that we have, or the parameters that we have available to set, are anomaly type. Again, we can set for above or below mean, and then sensitivity. And we see in the tooltip here, it's a relative scale. It's going to come down to how aggressive do we want it to be in finding anomalies. So let's say we want it to be fairly conservative and only find things that really stand out against the other images. We've got our input and output image folders set up. I'm going to go ahead and run this algorithm, and it's only going to be looking at a couple of images here using our standard process. Went ahead and analyze those. And now let's go ahead and jump into the results viewer. And you see the first thing that's going to pop up is this message, and we're using stock photos here that are provided by DJI. They're not geotagged, so that's why we're getting this dialog. It just gives us an opportunity to provide GPS information and location information for images if it isn't embedded in the metadata for whatever reason. So we'll go ahead and skip that for now and open this, and we'll see exactly what we were hoping to see, which is anomalies that are localized. So temperature anomalies that were localized. So rather than comparing the images of these vehicles against the entirety of the image, it compared it against the other things in its immediate neighborhood. So it basically identified each vehicle, or almost every vehicle, as being anomalous because it was anomalous compared to its surroundings. The other feature we wanted to look at while we are in the image results viewer for a thermal image is that histogram here. Now, as you recall, when we're looking at the histogram For the color image, it had the hue-based histogram, obviously not particularly valuable for thermal imagery. So for here, as you might expect, we're actually going to show a histogram based on temperature, and it shows us a very different view. So we have the ability to filter down the temperature range, or we see these orangish red identified marks here. And what that shows us is the pixels that have been identified as anomalous. So again, provides that histogram view so we can see where the anomalous pixels are, and we can see things that are truly outliers and key into those specifically, or we can adjust what temperature range is actually shown in the image. All right, closing out of that, we've got one more feature we want to look at. Back here at our main image analysis setup window one more time, we're going to look at this batch mode feature. And really, this is a gateway to a whole nother experience. And thank you very much again to John O'Keefe for building all this out. Setting the stage a little bit, what we're talking about with batch mode and search coordinator, which you'll see here in a second, is for large searches. So searches where we have thousands of images, where it's going to take a while to process all of them, and also quite a while to go ahead and review them. And oftentimes there's so many of them that we want more than one person to review each set of images. And all that can be accomplished through this batch mode and subsequent search coordination system that John created. So to start with, we'll go up here and select an input folder. And as we do, we see what batch mode does is it analyzes each subfolder of the input folder as a separate batch. So we're going to do it with some fairly small batches today, but you'll see inside here I have 3 subfolders. So it's going to treat each one of those as its own batch. And I'll go ahead and set an output folder. And just for simplicity, we'll use our good old color range friend and go ahead and start the batch mode analysis. And you'll see what it's doing is it's going to do each one of those subfolders separately. If these were larger runs, what that would mean is the output from batch 1, batch 2, etc. would be available as the subsequent batches are being run. And that means that somebody can go in and start analyzing the results of batch 1 and then batch 2 before the subsequent batches have finished running. It also allows us to pull it into this search coordinator capability. And really, again, this could be its own video and should be its own video. But we're just going to scratch the surface here and talk about what it brings to the table. And as you see, opening the search coordinator gives us this dashboard view. It tells us how many batches there are, how many images there are that had AOIs flagged in them, how many of those batches have been reviewed, the total AOIs that have been flagged and reviewed, and all those sorts of things. So again, it's this large search, multi-person involved review process that we're trying to manage through this search coordinator feature. Again, we're not going to go through all of this in full detail here at the end of this video, but we'll go ahead and make a subsequent video talking specifically about search coordinator. But for now, what we can see is we have the dashboard here. We can go in and look at the individual batch statuses. So we have our 3 batches here. We see none of them have been reviewed. We can click on one, and then we can either double click on it or click on review selected batch down here, and that'll open it in the viewer experience. So it's just like you're going in to do image analysis review of just that subset of the larger set of images. And again, the purpose of this is we're going to have multiple people go in and review the same set of images, or at the very least, we're going to start reviewing batch 1 and 2, or 1 before batch 3 has completed its analysis, so that we can start that process, find areas of interest, report them back, and get them to the teams before we fully have completed the rest of the analysis. So it's an ongoing process. that is what we had to cover today for the ADIAT version 2.1 launch spotlight. Thank you again very much for your interest in ADIAT. And as always, if you have any questions, concerns, comments, or are interested in contributing directly or indirectly to ADIAT, please feel free to reach out.